Here we are going to see how to create a multi-node Kubernetes cluster in a Ubuntu machine. First, what we are going to do is set up the machine for the deployment of Kubernetes packages. That means we might have to deploy some of the required packages, some configuration need to be changed, firewall need to be changed. All those things we'll do as the first step. Next, we are going to deploy the container runtime interface. Here we are going to use the containerd as the container runtime, and we are going to use the Docker distribution of container runtime. Next, we'll deploy all the Kubernetes packages. After that, we'll do the cluster creation. Then we do the node join. That means we'll have one master node. The worker node need to be joined to the master node. That we will do. Then the container network setup we will do. That is a CNI setup. This CNI is required mainly for the communication between the ports in multiple nodes. Also, this will manage the subnet for that Kubernetes node, and it will assign IPs for the ports. Machine configuration, then the container runtime installation, Kubernetes installation, all these we will do in both the machines, both the master node as well as the worker nodes. Then the cluster creation we'll do only in the master node. Then worker node will be joined to the master node, then the container runtime setup. Let us see how to deploy our Kubernetes cluster now. I have two machines here. First one I am going to use as the master node. The second one I am going to use as the worker node. I am using Ubuntu version 22. Same thing for worker node as well. I have changed my user to root user so that all the permission will be there. If you are using as a sudo user, you can add sudo in front of each of the commands. First, what we'll do is we'll name our machines. This is mainly for our convenience. The first one is the master node, and the second one we'll take it as the worker node. Now we discussed we have to do some initial configuration in the machine. That includes one of it is we are going to switch off the swap because Kubernetes works well without swap. Let us disable swap in both the machines. Next one is we are disabling the firewall. Actually, in production environment, it is not recommended. We are supposed to enable each of the required ports. Here, for again for the convenience, we are disabling the firewall. Next, for the HTTP communication, what all packages required, we are deploying it. Some of the package might be available in your machine by default, but you can install whatever is missing. Now let us add the BR net filter and the overlay modules. These are required for the communication between Kubernetes pods across the cluster. These parameters we are adding to the config file to persist across the reboots. Here you can see that we are enabling the IP tables and port forwarding. Let us add into the config file. We are enabling this without a system reboot. See, our initial mission setup is done. Now what we are going to do is we are going to install the container runtime interface. Here we are going to use containerd. We are going to use the Docker distribution of containerd. For that, we are going to download the public signing key of the Docker. Now let us add the Docker apt repository. Here we are going to install the containerd. We are looking to a specific version of containerd because sometimes if you are taking the latest version, this latest version may not match with the Kubernetes what we are deploying. To avoid that, we are going with a specific version of containerd. Now let us create a default containerd config file. In this config file, we have to do some change in this specific location because we are going to use systemd as the C group driver. Let us edit that config file. We have made the change, and let us restart containerd. If you want to check the status of containerd, we can run this command, and we can see that it is active and running in both the machines. Now containerd installation is done. Now what we are going to do is we are going to install Kubernetes. For that, let us download the Google Cloud public signing key. And add a Kubernetes apt repository. Now we are going to deploy Kubernetes. In Kubernetes, first one, this kubeadm is a tool that will help us to create cluster easily. Then kubelet is a node agent that need to be there in all the nodes. And kubectl is a command line tool through which we can push all the commands required to manage the Kubernetes cluster. We are going to deploy Kubernetes 1.26 version. Now we have installed the container runtime interface, Kubernetes. Now let us create cluster in the master node. We are creating the cluster with the CIDR range, this one. We are using this range because we are using Flannel as the container network interface. There this IP range is configured. If you want to change this IP range, you can do it. You have to change both in the cluster creation as well as in the Flannel config file. Here the deployment is giving some instructions. If you are not running as a root user, then run this command so that it will set up the configuration for running our command line tool. Otherwise, you can, if you say root user, you can use this one. It is configuring where is the admin.config file. Here I am running as a root user, so I am just setting this parameter. One more command is given here. It is what command need to be run in each of the worker machine for joining to this cluster. Before that, let us run a kubectl command. It has only a control plane node. We haven't joined our worker node to this cluster. So let us do that. Now the worker node has joined the master node. Let us check the status. Yes, now we have both the machines. But the status, you can see that both are not ready. This is because we haven't deployed our container network module. Let us do that. Let us check the status again. One of the node is ready, the other one is getting ready. Let us try again. Both the nodes are ready now. Here you can see that for the worker we haven't assigned any role. If you want to assign a role to the worker node, you can run this command. You can see that worker node is given the name worker and control plane is having the name or the role control plane. We have created a multi-node cluster. Now let us see whether this cluster is working. For that, we are going to deploy Nginx application in our cluster. I have a deployment for YAML file here. In this, it says to deploy the Nginx image and create 3 replicas of the ports. And the deployment name is the Cube Nginx. Let us deploy the application. We can see that our Nginx application is running. We are getting the output as well. So our cluster is working fine, and you can see that our ports are deployed into worker node, and so that means that the worker is joined to the master and master is managing the worker and the configurations. The commands given here will work for most of the Linux machines. Some change could be maybe your Linux may be using yum instead of apt, so do such changes. If you are running as a sudo user instead of a root user, just add sudo in front of each of the commands. Hope you know how to create a Kubernetes cluster in Linux now. If you follow these simple steps, it's easy for you to create the cluster.